Hello everyone, welcome back. In this video we are going to talk about magic square. So I'm going to show you two examples of magic square. This has a dimension of 3 cross 3. This has a dimension of 4 cross 4. Now let's talk about what is a magic square. A magic square is one which has n cross n dimension, right? So first condition is that matrix should be a square matrix. This is obvious condition. The second condition is that sum of all the elements of a particular row, let's name it R1. Sum of all the elements of row 2, let's call it R2. Sum of all the elements for row 3, let's call it R3. Now these should be equal. What does that mean? All the row sum should be equal to each other, right? And same rule is applied for the column as well. Sum of all the elements of an individual column should be equal to the sum of all the elements of all other columns, right? And there is one more condition that you can use all the elements from 1 to n square exactly once. So since this is a 3 cross 3 matrix, so I can use all the elements from 1 to 3 square, that is 9, exactly once. The leading diagonal and the let's say from top left to bottom right diagonal and bottom left to top right diagonal, these two diagonals should also have same value if I sum the elements of these diagonal elements. So let's talk about how can we build our magic square of n cross n dimension. Let's go to the next slide. First of all, let's talk about what particular sum should be calculated for a particular row. That means if there is a n cross n matrix, then what should be the sum of elements of a particular row? How I'm going to calculate it? Now, as I know that for n cross n matrix, each of the cell can have a value from 1 to n square, and each of the values will be used exactly once. That means the sum of all the elements of this particular matrix will be something like this. And I know the sum of natural numbers, capital N natural number, is n plus 1 by 2. So if I replace capital N as n square, then in that case sum of n square natural numbers will be equal to n square plus 1 divided by 2. Now I know the sum of all the elements of this magic square. Now in order to find the sum of all the elements of a particular row, I'm going to divide that particular sum by number of rows. And I know the number of rows is how much? N. So just divided by n. In that case, I will get the sum of a particular sum of all the elements of a particular row as n square plus 1 divided by 2. So this is basically the target sum which I should seek for every row, every column and every diagonal, right? So let's talk about how backtracking is going to give us solution for these magic squares. First of all, let's erase everything, and now I'm going to show you the approach. Now since by having the dimension of the square matrix, I'm able to calculate the target sum. I will store it in a target variable, and initially after creating n cross n matrix, I'm going to give initial values as 0 for all the cells. Let's consider this particular matrix having n equal to 6. Now what I'm going to do, first of all, assume that all the initial value of all the cells is 0. Now I will just try to insert a particular element from 1 to n square. This is my domain. So I'm basically going to loop through 1 to n till n square, and I'm just going to check if that particular number can be inserted at a particular position or not. So I'll start with the first row and first column. I will insert 1. Now after inserting that particular element, what I am supposed to do, I am supposed to check if that particular number can be inserted at this place or not, and how I am going to do it. For I'm basically going to calculate the sum of elements for this particular row. For example, for this row, for this column 0, what I'm going to do, I'm going to find the sum of all the elements before this particular element. For example, if I have inserted element 5 here, so I'm going to calculate the sum of all the elements for that particular row before it, right? And additionally, I'm also going to find all the, for example, if this particular row 2, I have inserted an element 3 here, I will initially find out the sum of all the elements in that particular row before that element position where I've inserted 3. So I'm just going to check some of the all the elements in the particular same row and sum of all the elements before this element in the same column. And I'm just going to check, let's name this as capital R, name this as capital C. So what I'm going to do here, in order to check whether a particular element can be inserted at a particular position, let's say this is the particular column, this is the particular row, the element inserted here is 3. So I will find sum of all the elements for this particular column, sum of all the elements for this particular row, and before inserting this element 3, I will just check if C plus num is basically the element to be inserted, is less than equal to the target. Additionally, if R plus num is less than equal to the target and that particular num does not exist in the set, I will create a set where I will store the elements which have been inserted so far in that magic square. So I'm just going to check if that particular set does not, that particular element does not exist in my set. If all these three conditions are satisfied, then only I'm going to insert a particular element. And once I have inserted that particular element, I'm going to change that element at that particular position. What I'm going to do here, I'm just going to, initially the value was 0, but now I have found that the element 3 can be inserted at this position. So what I'm going to do here, I'm just simply going to rewrite the value as num, and I'm going to call for the next column. For example, if I'm a particular row and I have found that this particular element x can be inserted, then I'm going to make a call for the next column for the same row. And once I have completed filling all the elements in a particular row, I will make a function call to the next row. And I'm going to check whether all the elements in the magic square has been filled successfully or not. In order to do this, what I'm going to do, once the row becomes equal to n, that means I have already filled I have already filled 0 to n minus 1 rows, that is I have already filled all the rows. And in that case, once I've got a solution, I'm just going to store it in an answer vector, or I'm just going to print it and increase the counter variable, which will show the number of solutions which I have received so far, right? So let's talk about how we can code this algorithm. So here you can see I have used a sample value of n as 4. I have created the 2D matrix and given an initial value of 0 to all the cells. The number of elements will be equal to n square, and I have calculated the target sum for a particular row, and I have called the create magic square function here. So here we will see the implementation of, let's change this function, print magic square, because we are going to print all the magic squares which we have received so far. So let's talk about, let's create a variable n which will be equal to the size of the matrix, and let's do the first thing as the base case, solution achieved. So if row is equal to the value n, in that case I know that I have already filled n rows, total n rows. from 0 to n minus 1. That means I have got one possible solution. In that case, what I'm going to do here, I'm just going to print all the elements. First of all, I'm going to increment the counter variable, and then I'm going to print all the elements of that particular solution. So first of all, I'm going to iterate through all the rows. After this, for a particular row, I'm going to iterate through all the columns. And then I'm going to just print it. And after printing a particular, after printing all the elements of a particular row, I'm just going to give a new line space. Now, this particular base case is for when the solution has been achieved. Now let's talk about the backtracking part. So as I have said, I'm going to check from all the possible values from 1 to n square. So let's take the num from 1 and iterate it till n square. Now you can see here I have already created an ordered set here. So what is the first condition which I have shown previously? First of all, the element num should not have been already inserted previously. So I'm just going to check if s.find num is equal to s.end, which means the element num is not present in the set. And I'm going to create another function which will check for that particular row and column. So row sum will be one function, we do not need it here. This function will basically find all the elements before the row and column position. It will basically find the sum of all the elements before that particular position. So let's pass the matrix here, row and the column. Now this sum should be less than equal to the target, and same goes for the column sum. Again, this sum should also be less than equal to the target. If this is the case, I'm going to insert the element at row and column position. So first of all, I'm going to insert the element in my set, and I'm going to override the value at row and column position. After this, I'm going to make a call for the for same row and next column. Row will be same, column variable will be incremented, target will remain as it is. And once I'm done with this, I'm going to erase that particular num and change the value at particular position to again 0, which was the initial value. Now this is basically our backtracking part is done. Now we are going to implement another base case where I'm just going to check if all elements in a particular row is filled. I'm going to check it. Just use this condition, which means that all the elements have been already filled. Now what I'm going to do here, before moving further, I cannot move further if I have filled all the particular values, because let's say this condition is there, if n is equal to 3 and for a particular row I have filled 1, 2 and 3, right? I've already filled 1, 2 and 3, but here the sum of all the elements is not equal to 15. The sum of all the elements is equal to 6, which means I cannot proceed to the next row, right? So before moving to the next row, I need to make sure that sum of all the elements in a particular row is equal to how much? Is equal to the target sum. So let's check it. If column sum matrix row column is equal to the target, then in that case I'm just going to print I'm just going to make a function call for the next row. And before moving to the next row, see, if a particular configuration, let's say if a particular configuration for a particular row is something like this. Now here you can see the sum of all the elements for the row 1 will be equal to 15, right? So we can successfully move to the next row. But when you have moved to the next row, we need to start from the first column. So that is why what I'm going to do here, I'm going to pass the column as 0, target will remain as it is. After this I'm just going to return, right? So what will happen now? If a particular configuration of all the elements in a particular row is such that the sum of the elements is equal to the target sum, then in that case I will successfully move to the next row. Again, if the condition is satisfied, again I will move to the next row. Again the condition is satisfied, again I'm going to move to the next row. And now when row becomes equal to 3, I have started from the row 0. Let's name it row 0, row 1, row 2. Now since I've moved to the row 3, which is equal to the dimension of the matrix, I will simply print the solution. So one more thing which I am supposed to do here is to check the sum of the diagonal elements, right? So I'm not just going to simply increment the counter variable. I'm first of all supposed to check the sum of the diagonal elements. Are they equal to the target sum or not? I'm just going to parse the matrix, and if the condition is satisfied, then in that case I will increase the counter variable and I will print all the elements of that particular magic square, and I'm just going to return from the function call. Just return. Now here you can see the implementation of row sum and column sum has still not been provided, so I'm just going to implement it. Let's name a function row sum, which is going to take the matrix it is going to take the particular row, column and target. Here I have now passed the target here, so I'm supposed to pass the target as well. Here as well I will pass the target. Now let's see the implementation of row sum. So what I'll do, I will create two temporary variables. I will store as row, j will store column. I will create a sum variable which will be initialized with 0, and what I'm going to do here, I'm just going to decrement the column value while j is greater than equal to 0, then in that case I will update the sum variable matrix I j, and I'm just going to decrement the j here and just return the sum. The same thing I'm going to do for column sum as well. Column sum. Now here what I'm going to do, I'm just going to decrement the variable representing the row I minus minus. Now again I'm going to implement the same thing for diagonal sum as well, but here the return type will be bool because I'm going to check the sum of diagonal elements for both the diagonals. So how I'm going to check the diagonal sum? Let's discuss about the logic for that. So here you can see, if I write the indexing for all the matrix elements, then it will be something like this, right? Here you can see that for this diagonal the value of the row and column is same, the index representing the row and column is same for this diagonal, and for this diagonal you can see I plus j is equal to n minus 1. Here you can see the sum is 2, here as well the sum is 2, here as well the sum is 2. So in order to check if a particular element belongs to the second diagonal, you are just going to use this condition. So instead of using two loops for iterating each of the elements of this matrix, I will simply use a single variable I, initialize with 0, and I will just increment it till n. Sure. So initialize it with 0. So I will just check if I is less than n and can be calculated as the size of the matrix. Just increment the variable I after I have summed up that particular value. I plus plus. Let's name this as sum1 for the first diagonal, right? And now since I is equal to n, now I'm again going to change it. For the second diagonal you will see I is equal to 0 and j is equal to n minus 1. Is less than n and j is greater. We don't need to write this condition, it will be checked automatically. So I'm going to decrement the row and decrement the column as well. Sorry, increment the row and decrement the column. That's it. Just check the sum1 is equal to sum2 and sum2 equal to the target. Now we are good to go. Let's implement, let's compile and execute this function. I think there's some mistake in this. Here we are supposed to give the data type of this parameter as well. I'm not supposed to give the row and column here. That's it. If zeros, there is another problem here. Let's check it out. If column sum, yeah, here I'm not past the target, so simply pass the target as well. Yeah, what is this nonsense, man? Sum2 was not declared. Let's make two variables here. Sum1, sum2. No, not here. Here there will be sum only. For the diagonal sum, I was supposed to make a sum2 variable as well. And one more thing I am supposed to do here is to initialize I with 0 and j equal to n minus 1, right? Let's now execute it once again. Again there is some issue. Let's resolve it. Where is the issue, man? I think everything is correct only. Expected semicolon before curly braces on line number 66. Yeah, here we are supposed to have the semicolon as well. Let's now execute it. Target was not declared in this scope. Here also I've done the same mistake. Target has not been declared. Line number 29. I don't know why I have made the same mistake everywhere. I've just copy pasted the erroneous code. So it says the number of solution for n equal to 4 as 0. Which should not have been the case. Let's try with n equal to 3. I think there is some mistake here. Again it says the number of solution is 0. So let's check it out where we are getting the code incorrect. If row is equal to n, then I'm going to check the diagonal sum, return it. Let's check the implementation of diagonal sum. This one is correct. This one is also correct. So here what I'm doing, I'm started with n equal num equal to 1, n square row sum less than equal to target and column sum less than equal to target. Then I'm going to simply insert the number in set matrix row column is equal to num and print magic square is called the print magic square function. Here is num and I want to check if all the elements have been filled for a particular row. I've just checked column is equal to n. Yeah, here I'm doing something wrong. This is the place where I'm doing wrong. So what I'm supposed to do here, I'll just explain it. Just going to erase everything. So for a particular row, I'm just supposed to check is the sum of all the elements is equal to the target sum or not. So for this particular row, I'm supposed to pass the position as column minus 1 because column has been reached to n now, right? So here I'm supposed to pass column minus 1. Secondly, I'm supposed to find pass row sum here, not the column sum. So this is again my mistake. So here it shows the number of solution for n equal to 3 as 82, which is not correct because the number of solution should have been n. So again, what thing I can do here is that I can simply just check. Let's see it once again. Consider this solution. Here sum of all the row elements is equal to 15, which is correct. But sum of the first column is not correct. Here it says 9 3, the sum comes out to be 20. For the second column it comes out to be 15. For the third column it comes out to be 10. So we are supposed to check this condition as well. So once we have reached to the last row, what I'm supposed to do, I can simply iterate through all the columns. Bool check equal to true. I'm simply going to iterate through all the columns. Int I equal to 0, I is less than n, I plus plus, and I'm just going to find the column sums. If column sum row column target, now I'm supposed to write row as n minus 1, column will be equal to I, and I'm just supposed to check if this is not equal to the target, then in that case just return, right? You don't need the bool variable here, simply return from here, and if it is this is not the case, in that case we can just increment the counter variable. That means a valid solution has been found. Now let's check again. It is going to give us some error. I knew for sure. I'm passing n minus 1 for So the column sum is supposed to take matrix as well. Yeah. So now you can see all the solutions are correct. I'll just give another column gap. I will give a new line gap so that these can be segregated with each other. Now let's try to find out the number of solution. So now you can see all the possible solutions for the magic square to be. So this is the first magic square. Here you can see the sum of all the row elements is equal to 15. For this one 15, for this one as well 15, for this column 15, for this one and for this one, and the sum of diagonal elements are also equal. Let's try for a different value. Let's check if a magic square is possible for n equal to 2. So magic square for n equal to 2, it does not exist. This is giving us correct answer. Let's try with n equal to 4. It is giving us solutions. It is still in the process of finding solution. Yeah, now we are good to go. I think there will be many solutions, so let's stop the running process. Let's focus on one of the solution with this one. So here you can see the sum of all the elements is equal to how much? 34. For this one as well 34. So sum of the all the rows, sum of elements for each row is equal to 34. Sum of elements of each column is also 34, and sum of the diagonal elements is also 34. 8 plus 7 15, 15 plus 3 18, 18 plus 16 34. This also comes out to be 34. So the mistake which I had done previously was that while going to the next column, I am checking if the whatever sum I have achieved so far is equal to the target sum or not. But once I have the row is equal to n now, that means I have already filled all of my rows. I am also again supposed to I'm supposed to check if the column sum which I have achieved so far for are equal to the target or not. If that will not be the case, then wrong solutions will be given, where although the sum of the elements for each row are equal, but the sum of elements for each column are not equal. So that is why previously we were getting 82 for n equal to 3, but after rectification of the code we are getting 8, which is the correct answer. That's all for the video. See you in next video.